Okay, say I have this 3D wave source here with power P. So it's a three-dimensional wave, meaning that this wave is going to propagate its energy three-dimensionally. Left, right, up, down, coming out of the page, into the page. So the intensity of this wave is going to decrease as if you are further away from the source. The reason is because this power is spread over a larger and larger spherical area. So the intensity of this wave can be written as P over 4 pi r squared, because the formula for the spherical area is 4 pi r squared. So that tells us the intensity of a wave is proportional to 1 over r squared, coupled with the fact that intensity is proportional to amplitude squared. We work out that the amplitude varies according to 1 over r. That's for a 3D wave. Let's consider a 2D wave, so with power P again. So this is a 2D wave, so it's going to propagate its energy left, right, up, down, but not into or out of the page. So if you're further away from the source, the intensity of the wave is smaller because this power is spread over a larger and larger circumference. So the intensity of a 2D wave is not written as P over 4 pi r squared, rather it's written as P over 2 pi r. 2 pi r is the formula for a circumference. That means intensity is proportional to 1 over r, coupled with the fact that intensity is proportional to a squared. We figure that the amplitude of a two-dimensional wave is proportional to 1 over square root of r. So you see, the formula for intensity and amplitude of a wave is different for a 3D and a 2D wave. In this question, we are talking about ripples on the surface of a pond, which is obviously a 2D wave. So we are going to make use of this relationship here, rather than this one. Easier way to apply this equation is perhaps to see this as a times square root of r is a constant. So the initial amplitude times the square root of the initial distance from the center should be equals to the final amplitude, which is what we're supposed to solve, multiplied with the final distance from the source, which is 1200. So this should give you the correct answer of amplitude being 0.71 mm. Okay, that's it. Ta-ta!